All right, we have these two systems that we want to solve by graphing. Now, if you're graphing a linear equation, one of the easiest ways to do it is to find the intercepts. And let me just check one thing here. Okay, I just wanted to make sure that we had covered what I thought we covered. So, because I'm doing the same thing kind of in three classes. I'm talking about linear equations in all my classes right now. I want to make sure I wasn't confusing something. Okay, so, I'll comment on the homework that people turned in, those who turned in, submitted the document for their homework. I saw a bunch of equations and a bunch of algebra, but I didn't see any graphs. So I'm not sure what you're looking at to get your solutions, because it doesn't seem that you're looking at open math videos, and it doesn't seem that you're looking at what we've done in here. So if you just look up how do I solve this system of equations, you get a lot of explanations, you can get a tutorial and everything, but it's probably going to give you the algebra. So if that's one possibility. I have a hard time explaining why people aren't using graphs, but I'll just say, make sure you know what we do in class. I'm giving you the whole detail and telling you, here's how you write it out if you want to understand it, so you don't forget it when you come in Monday, okay? You take the time to do that, or take good notes from Open Math and let them explain it to you. Or find another place that explains it but doesn't do it for you, okay? All right, so you just find the x-intercept by letting y equal 0, because here's your x-axis. Now here's your y-axis, so here's your x-axis. Y-axis is the line x equals 0. Everywhere on the line x equals 0. You got to really understand that so you can use it, because you have to use it repeatedly through a pre-calculus course and through much of this course. So you want to lock that in. Lock in the fact that the y-axis is when x equals 0, which makes perfectly good sense. And the x-axis is the axis where y equals 0. Everywhere on the x-axis. So if you let y equals 0 and solve this equation for x, it'll give you the x coordinate of the point on the y equals 0 line, which is the coordinate where the graph is going to go through the x-axis. So, and I prefer to label the line x equals 9. I really would prefer that you do that because it reinforces what you do. So I put these graphs up here in all my classes. I put these graphs up here, tell you how I recommend that you work these problems out, and almost nobody's doing it. Except the 4 people that made A's on my test in pre-calculus. Okay. You don't have to do it that way. I'm not requiring it, but you learn what there is to learn if you do that, okay? Write these things out the way I'm writing them out. Okay, anyhow, there's the x-intercept of this line. The y-intercept Well, y-intercept lies on the y-axis, x equals 0 on the y-axis. So if we replace x by 0, we get 4 times 0 minus 9y equals 36. Then you divide both sides by 9, you get y equals -4. So I'm going to draw a line across here and label it y equals -4 and put a mark here on the y-axis 4 units below the origin. And that gives me 2 points that I can connect with a straight line. I kind of drew it a little bit too low, so my estimate of the intersection point that we're going to eventually get isn't going to be totally accurate. But I didn't want to do it perfectly because I'd hate to show off. Well, anyhow, so we have this and we label this. This is a line 4x minus 9y equals 0, equals 36, sorry. Don't leave this stuff out. Write it down and you'll begin to understand it much better and you'll retain it much longer. Okay. Then for the second line, I'm thinking ahead to right equals 0. It's 24. Y equals 6. Now, I'm not writing out all the words. I've done this already, so you should go back and look at all the words that I've written out. But we have we do the same thing for the second line. We get the y-intercept by letting x equals 0. We get the x-intercept by letting y equals 0. Now, when you do this, I strongly recommend you write out x-intercept when y equals 0, y-intercept when x equals 0, so that begins to make sense to you. If you're not writing it out, you're not going to get it as well. So, thanks. Okay, so now we have y-intercept, y equals 6. So let's see, y equals 4 here. I say y equals 6 here. Put a mark here. And then x-intercept, x equals 4. When y equals 0, x equals 4. So let's see, if this is 9, then 4 is about here. And now I can sketch a line, straight line through these points. Make sense? Hopefully it does. Okay. Then we mark the intersection point. And we estimate the coordinates of the intersection point. So we do a little projection line here. And a little projection line here. And x values are all the same on this vertical line. So x is between 4 and 9, a good bit closer to 4 than it is to 9. It looks like it's about 5. So I'll say it's about 5. And I won't have a lot of faith in that because it's a hand-drawn graph. And y equals what? Well, y is 4 here. It's pretty much about halfway between 0 and 4. It's a little less. I think it's a little less than 2, but I'm just going to say y equals 2. And I put a little wavy symbol here to show it's approximately equal. Now, is that solution any good? Well, I'm going to say I don't think it's going to be a lot of good. Doesn't look like it's much good at all. It can't be because, of course, oh yeah, okay. And I said y is approximately 2 here. It's approximately -2, right? Down below the x-axis. Okay, so if I put in 5 for x here, I get 20. If I put in -2 for y, I get 18. 20 and 18 is 38, which is pretty close to 36. I'll write that out in a minute, but just telling you, I'm putting 5 in for x and 2 in for y and see if these equations appear to be approximately right. So if x is 5 and y is -2, you can put 5 in here, -2 here, do the arithmetic, get 38 when you're supposed to get 36. And that's really not bad for a hand-drawn graph. Then you do the second equation. X is 5, so that's going to give you 30. Y is -2. -2 times 4 is -8. So I get 30 minus 8, which is 22. 22 equals 24. That's pretty close. So this is much closer than I thought it was going to be. So we check. So I'm going to do the check here. I'm writing that kind of small. I say we check the solution x equals 5, y equals -2. 4x minus 9y equals 36 is 4 times 5 minus 9 times -2 equal 36. It's never going to come out right. Let me fix that. Well, we get 38 equals 36, which I say is close. Now, I'm not writing all this out in all the detail. I should be reminding you of what open math tells you to do to check these. When we do the arithmetic for x equals 5 and y equals -2, we get 22 equals 34. Up here we got 38 equals 36. Those are pretty close. So we know our solution is pretty close to 36 to x equals 5 and y equals -2. All right. Now, the second equation we solve by substitution. And in a little while, we're going to come back and solve that first equation by elimination. But right now, take our second equation, second system, and solve by substitution. We have 3x minus 9y equals 5. And x equals 3y plus 4. Yeah. Substitute. This in the first equation. We get, okay, instead of x, we can write 3y plus 4 here. So we get 3 times 3y plus 4 minus 9y equals 5. We multiply through by the 3. 9y plus 12 minus 9y equals 5. And then this might have been confusing for some people, but 9y minus 9y is 0. And that simply gives us 12 equals 5. That's false. The solution does not exist. There's no solution. This cannot equal this. I mean, this and this cannot both be true. Now, if we had gotten a solution, as we did in class previously, we would get if we got a solution for y, we could put that back into the second equation and find out what x is. So let's just do one where you really can solve it. Let's take the first equation, 3x minus 9y equals 5. And let's say x equals 2y plus 4. I'm going to even say minus 2y, okay? So substitute negative 2y plus 4 for x in the first equation. What do we get? The equation that we get is 3 times negative 2y plus 4 plus 9y equals 5. Multiply through by the 3, we get negative 6y plus 12 plus 9y equals 5. Negative 6y and 9y gives us 3y. And then if you want to subtract the 12 from both sides by writing out the equation negative 12 equals negative 12 and adding these two equations, you get 12 minus 12 plus 3y equals 5 minus 12. I don't see people writing out this step. I see them doing this by superstition. Sometimes the superstition works. Sometimes you probably understand it. Some people probably understand it. People who don't just make a lot of mistakes. They'll subtract the 12 from the 3. You know, they'll do stuff. Write this out and take a good look at this, and you see, well, with 12 minus 12 gives us 0. That leaves us 3y. We're not going to subtract 12 from 3 here. If we write it like this. If we write it like this, a lot of people do. So I don't like that way of doing it, but it does have some advantages. So by all means, do this if that's what you've been taught to do, but do it right with an equal sign. And don't think that you can subtract this 12 from this 3. Okay, anyhow, we get 3y equals 7. So 3y over 3 equals negative 7 over 3. So that y equals negative 7/3. What do we do with that? We plug that back into the second equation. And the second equation comes out and gives us x equals -2 times -7/3 plus 4. Well, -2 times -7/3 right there is your answer for x. You just got to add -14/3 to 4. And if you've forgotten what you learned about fractions at the beginning of the course, you can't forget that. You can't not know that. So be sure you review that. So that's -14/3 plus 12/3, which is -2/3. And your solution set is -2/3, -7/3. If we put that into the first equation, 3 times -14/3 is -14. 9 times -2/3 is +18/3. No, sorry. It's 9y times -7/3. And that's +63/3. And still doesn't seem to work out, so maybe I made a mistake. Either that or I'm making a mistake in checking it. But anyhow, this is the procedure. If I made a mistake, find it and fix it. I'm not going to take the time right now. But when I check it, you understand if I put in -2/3 for 3x. Oh, I get it. Okay. I think maybe it's right. I get -6/3, which of course is -2. And I get +63/3. Which still doesn't give me 5. Pretty easy problem. Can't imagine what I did wrong, but I must have done something wrong. That's 12, that's y. It's 3y. It's -7. We get y equals -7/3. It was -7/3. We get, oh heck, look at what I did here. I did a really bonehead thing. Multiplied -2 by -7/3. And my eye didn't catch the negative there, and my brain wasn't engaged. Should have been +14/3. That should be plus. So this should equal 18/3. Well, 14/3 plus 12/3, which should be 26/3. And now that's going to work out because I plug this in here. 3 times 26/3 is 84/3, and negative gives us 15/3, which is 5. Okay. Make sure you understand the check. Okay, so I better write the check out. And I should write the correct solution step in here. Do we get 3 times 26/3 minus 9 times -7/3? Should equal 5. And that still doesn't work. I'm not going to take a lot of class time to figure out what in the world I'm doing wrong here. Making a mistake at some step. Thought I caught it, but it didn't. Can't see what's wrong with this. Get that for X. Of course, that's X. I'm still not writing my solution set out correctly. X is 26/3. Y is -7/3. Doesn't seem to work yet. So I don't want to fill around with it anymore. Something's haywire there. But the process is what I said. You take this expression and replace X by that expression. You can solve it for Y. Once you solve for Y, you plug it in to the other equation. Here's what you get, and you solve it. Okay. Okay, now I want to go on and solve the first system that we had. Four X minus 9Y equals 36. And 6X plus 4Y equals 24. Now watch what I do here, and I recommend that you imitate it. Circle 1 and a circle 2 means this is equation 1 and this is equation 2. If I multiply equation 1 by 3, and multiply equation 2 by 2, multiply by -2. Well, write down for me, what do I get if I multiply do this and write this down, but somewhere else in your paper, so it doesn't interfere with what we're doing here. We want this problem to develop straight down the page. We don't want to write anything else in here until we're sure it fits. So over here, or if you're writing this on the left side of your page, which is likely, write this on the right side of your page. But what do you get when you multiply both sides of this by 3? What do you get when you multiply both sides of this by -2? Okay, well, what do we get? We get 3 times the quadrant of 4x minus 9y equals 3 times 36. Multiplying both sides by 3 doesn't change the solutions to this equation. That gives us 12x minus 18y equals 108. Now, what we're wanting to write down here is 3 times equation 1. Well, there's 3 times equation 1. I multiply 3 times equation 1. I mean, multiply 3 by both sides of the equation. I don't want to have to write out and multiply by both sides enough. We understand we're multiplying both sides and everything on both sides. If one side has 2 terms in it, we use a distributive law. So we get 12x minus 18y equals 108. Okay, then we multiply the second equation by -2. -2 times 6x is -12x. -2 times 4y is -8y. And -2 times 24 is -48. So we get and there are 2 equations. Now what we're going to do next is we're going to add equation 1 to equation 2. For equation 1 doesn't mean this equation up here anymore. Equation 1 is our most recent equation 1, that's this one. So here's equation 1, and here's our new equation 2, and we add the 2 sides. So see what you get, and then see if you do the obvious thing. Got a correction there. 3 times -9 is -27, not -18. Okay, when we add these 2 equations now, and remember, I strongly advocate that you do this the way I'm doing it. Your side calculations, if you got to multiply this equation by 3, do it over here so you got room for your solution to develop here. Don't mess with this space down here. Don't put anything down here except the relevant equations, okay? It's a system of 2 equations. However, when we add equation 1 to equation 2, and you want to write that down so you understand what's being done, so that if you look back later and see that there's something wrong, you know exactly what steps you took. Okay. Well, if we do this, we get 0x minus 35y equals 60. I think everybody who was participating in this problem got it. So we write down -35y equals 60. And now we solve. We no longer have a system of 2 equations. We solve for y. Now what we did here, we simplified the equation by getting rid of that 0x. Because that's just 0. And it's optional whether you write it down here or not, but I'm gonna be really complete when I write these things down. And negative 35y equals 60, how do we solve that? We divide negative 35y by negative 35. And that will equal 60 divided by negative 35. So negative 35 goes into negative 35 once, and we get y equals 60 over negative 35, which is negative 12 sevenths. And now what do? We take that negative 12 sevenths and we plug it into one of our equations. Okay. I'm going to choose to plug it into the second equation because the numbers are a little smaller. So I'm going to plug this in here. And out of that is going to come the equation 6x plus 4 times negative 12 sevenths equals 24. Applying my good judgment, which tells me don't work with fractions if you can help it. I do what I say to always do when you have an equation with denominators, multiply through by the common denominator. So we do now I'm going to do 2 steps at once here. I guess I'd better not do 2 steps at once. I'm going to simplify this before I do that. We get 6x minus 48 over 7 equals 24. That's going to be a little easier to look at. In other words, I multiply the 4 by the negative 12 and so forth. Okay, simplify that fraction. So I just have a simple fraction. Now I multiply 7 times 6x minus 48 sevenths equals 7 times 24. That gives me 42x minus 7 times 48 sevenths equals 168. Now 7 times 48 sevenths is just 48, because it's like 7 over 1 times 48 over 7. Another way to look at it is 7 is going to be the denominator of the fraction we get when we multiply these. And 7 is going to be a factor of the numerator, so we can divide a factor of the numerator into a factor of the denominator, giving us the equation 42x minus 336 equals 168. And let me make sure it's 336. Yeah, that works. 7 times 50 is 350, subtract 14. Okay. So, well, step you should include, but we get 42x equals 336 plus 168, which is, I think that's 494. No, actually, that's 504. So x equals 504 over 42. Now, let's see, 3 doesn't go, yeah, 3 goes into 504. And 3 goes into 42, leaves us 14. And, well, I'm not going to go through the rest. Equals this, we reduce that fraction. I don't think it reduces a whole lot. And then we check. In open math, I'll show you those steps. Key that I want to show you here is how you get these equations to match up so that when you add them, one of the variables goes away. That makes sense? So these equations don't match up. You can't get rid of the x's, you can't get rid of the y's by adding the equations. If you multiply this one by 3 and this one by 2, you can't. And the way you do that is you kind of find, it's kind of like finding a common denominator. You had a denominator of 4 and a denominator of 6, you would figure out that your common denominator is 12. That means there's something you can multiply by 4 and something you can multiply by 6 to get 12. So smallest numbers divisible by both 4 and 6 is 12. Often we're going to simply choose that number. Now there are other methods, including involving prime factorization, but I'm not going to talk about that today. I'll probably talk about it a little bit next time. All right. So let me give you another couple of problems. The trickiest step is getting the equations to match up. Okay. So see if you can get these equations to match up. So you're going to want something times equation 1 here, and something times equation 2 here. You work that out over to the left or to the right on a different part of your paper and figure out what your multiples need to be. Okay, so we're trying to find a number to, let's say, multiply by 5 and another number to multiply by 3 so that the numbers match up. Okay. Well, something that always works if you do 3 times equation 1 and 5 times equation 2. In other words, multiply this number by this number, multiply this number by this number, and then multiply this number by this number. It's always going to work. And then make one of them negative. Since they're both positive, you want to be able to add them. So put the negative on this one. So see what you get. Okay, if I did that correctly, here's 3 times equation 1. And if I multiply that out, I can see I have 3 times 5x, which gives me 15x, and negative 3 times, well, 3 times negative 3y, which gives me negative 9y, and 3 times 14, which is 42. And then negative 5 times 3x is negative 15x. Negative 5 times 2y is negative 10y. Negative 5 times 12 is negative 60. So if you do this step, here's what you get. And then you add the 15 and the negative 15, you get 0. And you get negative 19y equals negative 18. So y equals 18 over 19. Now, I haven't written that out in all the detail, partly because we're almost out of time. I can plug this back in, and I'm going to plug it into the second equation because it's got an easier multiplier. And the equation that comes out of that is 3x plus 2 times 18 over 19 equals 12. So that 3x plus 36 over 19 equals 12. I multiply both sides by 19. And I get this, which gives me 57x plus 36 equals 19 times 12 is like 20 times 12 minus 12. That's going to be 208. No, it isn't. Yeah. 232, sorry. 19 times 228. I'll get it right yet. Okay, so that's going to end up with 57x equals 191. I did that fast. I could have a mistake there. Double check. 19 times 10 is 190. 19 times 2 is 38. That adds up to 228. And subtracting 36 from 228 gives me 192. I don't know how I got 191 out of that. So the 7 and the 15. The 192 over 57. They're both divisible by 3. So that would reduce down to 64 over 19. And I think make myself a little note, check my arithmetic. Then you could plug both of these back into either equation, preferably the first, since you plugged everything into the second. Plug it back into the first equation. Multiply both sides by 19. And you should get equality.